Aloha, Richard Halverson here. This is ITS388AL. And today I'd like to show you how to add code into your program to do timing tests. And so let me share my screen here. I'm going to share this one. And so we have just completed assignment 8 in the last video. And so today I'd like to get us started with the last assignment here. And in this assignment, we're supposed to take, the test program in section 9.5 or, the bubble sort program that we started with in the assignment 8. Or you can start with your completed assignment 8. This should be assignment 8 here. All right, let's see. I think I fixed assignment 8. Okay, so I'm going to start with my assignment 8 and the modified bubble sort, and then I'm going to in this video I'm not going to add this yet, but I am going to add the ability to compare execution times of each algorithm. And in my assignment 8, I've got the original bubble sort and I've got my modified bubble sort. So I guess I can show you how to compare the execution times of those two programs. And then I think I may have another video. I'll have another video after this on how to load up special arrays so you can actually see the best case and the worst case and average case for these different sort algorithms. So let's get started here. I've opened up this is my bubble sort, my modified bubble sort program. And you recall that the regular bubble sort program has this outer loop. That's the outer loop. And then there's this inner loop here. And the idea is that if you, in one pass through the outer loop, which involves going down here and then looping through the inner loop all the way from the beginning to the end, if there are no exchanges that take place, in other words, if this code is never executed, the exchange code, then we know that the array is sorted already and we don't have to go any further. So that's what we did here with this additional, the second bubble sort program. Here we added a counter, which we used EBX for the counter, and we initialized it at 0. So this is something we added. Let's see, let me just add some comments here. We added this line. This initialized our inner loop exchange counter to 0. And then here we incremented our exchange counter if this exchange took place. And then at the end, after the complete pass of the outer loop, one pass through the outer loop, at this point right here, we tested to see if the exchange counter is still 0. If it's still 0, that means we went all the way through a pass in the outer loop without any exchanges, and then we know we're done. So if it's equal to 0, we jump out and we're done. So and then what we did was in the main program, this is the main program, we instead of calling our original bubble sort program, we called our modified bubble sort program, and we verified that worked. Let's see, if we execute this, let's just run this. Rebuild, and it's succeeded. So if we execute this, we see that here's the unsorted array, and hit the key, and then this is the sorted array. You see it starts out at 628, goes up to 9970, and then we're able to locate something like let's locate where 7781 is. this one right here, and it's the 39th position. All right. You recall we made the modification where we said the low value was going to equal 1 and the high value was going to equal 10,000. And we have 50 elements in the array. Okay, so the first thing I'm going to do is I'm going to add some breakpoints in here so we can see more clearly the memory array as it's being built. Okay, so to do that, I'm going to open up the fill array program, and this thing fills the array from fills this array, this many words, and this is the lower range and this is the upper range, and basically it looks for a random number within the range, and stores it. Store EAX into EDI. That's what this instruction does. And loops for the length of the array, which is the count. Loops that many times, and when it's done, it's filled. All right, so I'm going to stick a breakpoint right here, and I'm going to stick a breakpoint right here. So we should see the array, this P array, just before it starts being filled. The P array is going to be in EDI, so we'll be able to see exactly where the array is going to start. And ECX will contain the count, and it'll loop. And then the next breakpoint is when it's all done. So so if we run this, start debugging, and let's put this over here. And we're at the first breakpoint right here. And if we look at the memory right here, let's see, where EDI is 0040600. So let's find that. I'm going to drag this up here and press enter, and we're at 04406. Okay, this is the start of the array right here, it looks like. So let's run this one more time. So this loop, all this will take place, and we'll be down here, and the array should be filled. There it is. Okay, so this is the first element. It's 4 bytes long, and this is the last element right here. So that's 50. And then we can, let's just finish this out here. And this is sorted, and then we're done. Okay, so let's. I'm going to also add a breakpoint at the end of the sort. No, let's see. I'll add it at the beginning of the sort, right here, and at the end of the sort, right here. Okay, let's see what this looks like. So the other breakpoints are still there. The fill array breakpoints are still there. Okay, let's run this. And we're at the beginning of the beginning is right 046. This is the beginning, just like it was before. Continue, and now it's filled up. And then let's pop over to the bubble sort here, and let's continue again. We're at the beginning, right here. We can't see anything, and then we have to press any key. There we go. And so here we are at the beginning of the bubble sort, and this is our array. And so let's run it again, and now we see it's sorted. It's kind of hard to tell it's sorted. 005E is a small number, 00B2 is another, it's a little bit bigger, 021B all the way up to 26B4. Okay, so it looks like it's sorted. All right, The first thing I'm going to do now is let me. I'm going to create a copy. We can close this out. Okay, so to for this binary search to be able to test compare to be able to compare um, two sort algorithms, I want to make sure that I use the same array. So when I create this array, I want to store it someplace. And then when I invoke these bubble sort programs, I want to load the array to be sorted with the same array both times. So to do this, I need to create a copy array program. So I'm going to create a copy array program. I'm going to do right click, and I'm going to add a new item called copy array.asm. And I'm going to start out just using this code here. So I'm going to copy the fill array code, paste it over here into copy array, and I'm going to change all the occurrences of fill with maybe copy. Is this going to work? Let's see. Replace next. Okay, 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 okay. All right. So, and I'm going to need, I'm going to have a source array, and this is the pointer to the source array. And there's going to be a count, and then there's going to be a destination array. D array is a pointer to a D word. And this is going to be pointer to destination array. And I don't need that comma because I don't need this line here. And let's see, how is this going to work? I'm going to have a move P array. It's a move source array. Let's see. This will be the destination array. Move D array into the destination pointer points to the destination array. I need something that points to the source array. Move ESI S array. ESI points to source array. And then there's the count, and I don't need this or this or this. And let's see, my copy array program is going to move the source ESI into the accumulator, the EAX register, get source element, and then move into EDI, whatever EAX was, store into destination. All right. And then I don't need we're not calling any random number. We're not doing any of this stuff here. I guess I could have used this instruction. Okay, yeah, I don't need, I'm not going to use that instruction. So get rid of this, get rid of this, get rid of this. I need to increment add ESI, the source. I need to add 4 because it's 4 bytes per operand. Increment source pointer, and then add DSEDI 4, and that increments destination pointer. And then we loop, and we're going to loop ECX times and then we're done. All right, so copy procedure. All right, so let's, all right, now I need to also add it to the include file because I need a proto for this. All right, I use EAX, I use EDI, I use ESI, and EDI, ECX, I don't use EDX. I use ECX, okay, yes, okay. And I need to add a proto for this. The protos are, let me click up here and switch to folder view, and they are in this include file right here. And I need a proto for this, and it looks, actually looks kind of like this. So I want to just copy this, and this is going to be copy array. And there is a destination pointer and a count, oops, and a source, it's a D array, PTR, D word, and this should be S array. All right, that's a copy. All right, so that that takes, this is the proto for that. Let's go back to the solution here, Solution Explorer. And so let's look at binary search test. And I need to allocate another place for that array. This is for the first one, and I'm going to make one for the second one. I'm going to call it array 2. Is a D word. Same. Array size. Dupe. Question mark. And you know, I'm going to change the array size to 48 just so it lines up. And I'll leave that. And so I'm going to fill the array, and then I'm going to invoke copy array from the source is going to be ADDR array. That's the source, and it's going to be array size. And then I got to do an ADDR destination array, which is array 2. So this is going to copy this array into array 2. This fills this array, and this copies this array into array 2. All right. And then this prints, this is going to print the array. And then I want to, well, first of all, let's see if this works. Let's see, I've got my breakpoints here, and I'm going to put another breakpoint here and here. So we're going to see it copy it over. We're going to see it copy over. And that should execute right after this. All right, so let's build this. And it succeeded. Great. And then let's run it. Start debugging. And here we are at this breakpoint, and that's the fill array, and EDI points to same place, 00406,000, which is right here. And we're only going to fill 48 locations now, so let's continue. And now we're down here, and we see filled 48 locations. It's from 00 all the way to BF, looks like. And then we're going to go one more time, and this should go over into copy array, because after we're done with fill array, we go to copy array. So the next breakpoint should be this one in copy array right at the top. So continue, and we see that ESI is equal to the source, which is 040600. That's the source, 040600. And EDI is 0406C0, which is right here. So we should see this copy into here? Yeah, I guess so. We should see all of this copy starting here. Let's see what happens. Okay, I'm going to run it again, and boom, there we go. B8 or 12B8, 12B8, all the way down to 1ADC, D6. All right, so the copy works. And now we can click again, and we should still see this stuff up here, sort. So let's continue, and this thing pops up. We go to press any key, and we see that now we should see, where are we? We're at the top of the bubble sort. We haven't started the sort yet. Now let's do the sort, and lo and behold, it's all sorted, maybe. All right, so B12, okay, so the other array is still here. Okay, so let's stop this. So now that we've got that thing copying over, let's go back to binaries. This is the main program. What we want to do is we want to time, let's time this bubble sort too. Let's go back to, well, that's fine, we don't need to do that. Okay, let's add the timer in here. And the timer we're going to add, if we go back to our textbook, if we look on page 161 of our textbook, we see it's this GetMseconds thing we're going to use. And the way this GetMseconds works is, first of all, you have to allocate a place. Okay, so this is how you use it to figure out the execution time. What we're doing is we're figuring out, what's going on here? We're figuring out the execution time of the loop. And so first of all, we get the milliseconds, the current time, and that's what it is it's the number of milliseconds since midnight. So we get the milliseconds reading, we store that into start time, and then we do our loop, and then when we're done with our loop, we get the milliseconds, the elapsed time milliseconds or whatever, and then we're able to subtract the new milliseconds from the start time, and we subtract it, and then what's left over in EAX is the amount of time that the number of milliseconds that it took to do the loop. Okay, so I'm gonna, well, I'll just put this over on the side here, and I'm gonna make this a little smaller for the moment. So I'm gonna copy this in there. All right, so first of all, I have to put up at the top here, let me throw in some byte values here. I'll put start time is a D word. And then I got to put some labels in here. I'm going to put a millisecond label. MSEC is a byte. And it's going to be, I'm going to do space milliseconds. Space. Quote, comma 0. And is that all I need? I think that might be all I need right now. Okay, so let's throw this in. Call get milliseconds, and so it's going to return it in EAX. Get milliseconds from midnight into EAX. And then I'm going to I'm going to store it into start time. I'm going to store EAX into start time. Store into start time. And then I'm going to go on my merry way, execute this bubble sort. And then when I'm done, I'm going to get the start time, call get milliseconds again. Get milliseconds again into EAX, and then I'm going to subtract EAX from start time. No, subtract start time from EAX. And this will get loop time, compute loop time. compute bubble sort time. Whatever. And then I want to display it out, I guess, here. So I'm going to, let's see, to display it out, I simply write call write decimal. So that's going to write it out. And then I'm going to output milliseconds. And then I'm gonna display out this MSec thing up here. So I'm gonna say, to do that, I move into EDX offset of MSEC. That would be this thing, MSEC. Move that into EDX, and then call write string. Okay, and I got to add some carriage turn line. I got to add some new lines here. CRLF. I'm gonna put some more in here. Let's just see how this works. Okay. Let's just see what this looks like. All right, I'm gonna build the project. Succeeded. All right, debug, start debugging. And I guess we don't really care too much about what goes on out here, so let's just execute this thing. Let me stop this. I got to get rid of these breakpoints. Get rid of that breakpoint. Get rid of this breakpoint. Get rid of fill array breakpoints for now. And let's start this again. I can just do debug. So that's our unsorted array. What happened? Am I at a breakpoint? Oh, I left a breakpoint. The bubble sort breakpoint. Let me get rid of that bubble sort breakpoint. Let's what happens. Hit any key. I think. Oh, I gotta hit this thing. Continue. Now hit any key. Oh, okay. All right. Oh, it took that many milliseconds. Why? Because it was waiting for me to do something. It was waiting for me to undo that. Okay, so let's just run this again. Let's run it again. I got rid of that last breakpoint. Okay. Got this here and hit any key, and it's 0 milliseconds. Okay, the reason it's 0 milliseconds is because it runs really fast and it's taking microseconds and not milliseconds. So let's what I want to do is I want to run this thing. Where's my here? I want to run this thing like a bunch of times. So to run it a bunch of times, okay, I want to start the timer, run this thing a bunch of times, and then call the timer again. Now to run this a bunch of times, I want to keep running it. The first time I run it, it's going to sort the array. And then the next time I run it, I want to run it on the unsorted array. So this is where I'm going to use my copy array thing. So right up here, I'm going to say invoke copy array, and I'm going to copy it from array 2, ADDR array 2. So before I copied the filled array into array 2, now I'm going to copy from array 2 back to the filled array. So we're working on the same array again. Okay, so that's going to copy the second array back into the first array, and then it can do the sort again. All right, so then I want to do it a bunch of times. So I'm just going to move into ECX 100,000. I'm going to loop 100,000 times. Execute 100,000 times. And after I've bubble sorted, I need to loop to LP underscore bub 2. Okay, how's that? Bub 2. LP bub 2, because this is bubble sort 2. All right, so it's going to do it 100,000 times. All right, let's see what happens now. Let's build it. Rebuild the solution. Looks, ooh, it failed. Bub 2, error, syntax error, bub, ooh, I gotta put a colon. All right, let's try it again. Succeeded. All right, now let's execute. And we get, there's that. Now it's running 100,000 times, and it took 1,291 milliseconds, or 1 second, 1.291 seconds. That's how long it took. All right, so that's fine. Now I'm going to run, I want to compare the times. Okay, so basically I need to copy this. I want to invoke this bubble sort too. So let's, I'm going to copy this whole thing. Oh, I'm going to include the print array. So this calls it, stores it, runs it 100,000 times, gets the timing, and prints it out. Okay, so I'm going to copy this, and I'm going to paste it again. All right, so this is the second one. So this up here will be the first one. So I'm going to make this just bub nothing. I'm going to change it to just bubble sort. All right, so this here is run first bubble sort. Run original bubble sort. And this here is run modified bubble sort. Okay. All right, and it's going to use the same array. And it's going to run it 1,000 times. And I tell you what, I want to put some labels on the top here. Okay, so I want to make a bub 1 is byte, and I'm going to say original bubble sort, quote, comma 0, and I'm going to say bub 2 is byte, and it's going to be called modified bubble sort, comma 0. Okay, so now we've got these labeling things here, and so I'm going to label them at the very top here. Original bubble sort, I'm going to say, I go move edx, comma, bub 1 for the original bubble sort header or title or something. And I go call write string, right? Looks just like this. I'm going to throw in some CRLFs. Call CRLF. And after here, I'm going to call CRLF. And I'm going to run the thing. And let me just grab this here. And I'll run it, and then I'm done. And it prints it out. And then here I'm going to do again bub2. And this is modified. Call write string, run that, run that. Okay, so this is, let's see what this does. Build, rebuild. Ooh, failure. Let's see. Instruction operands must be the same. 40? 40? Instruction. Oh, no, I'm doing this wrong, aren't I? Offset. 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 Yeah, that's better. Let's build this. Succeeded. All right, let's debug this. Start debugging. And we've got original bubble sort, modified bubble sort. And the original bubble sort took 1,686 milliseconds, and the modified bubble sort took only 1,211 milliseconds. And we don't need to do this. All right, let's run this again. I'd like to see. It's going to be a different array because it's a random array. At this, and then we got boom, boom. The original took 1,419 milliseconds, and the modified took only 1,087 milliseconds. All right, so let's see. Let me unshare this. All right, so what I've shown you is how to add a copy array to your bubble sort program, and then how to add timing in there, and how to use copy array so we make sure that each time so we can run our array a bunch of times, run our sort program a bunch of times, like 100,000 times, and it'll be sorting the same array every time, so we copy it in. And then when we compare these sort routines, we use the same array, and that way we're able to compare apples and apples, as they say. All right, hope this helped, and see you next time. Thanks for watching.